Hello friends, welcome to my channel. This is Thermodynamics part 4 for Isro examination 2017 quick review. From Thermodynamics 7 to 15 questions they will ask. Every year they are asking 7 to 15 questions. Clapeyron equation or Clapeyron equation. This is only Clapeyron equation. dp by dt equal to hg minus hf divided by t into vg minus vf. We can write it as dp by dt equal to hfg by t into vfg whenever fluid is changing phase. Next is Joule Thomson coefficient. This is very important. Temperature versus pressure curve. Joule Thomson coefficient mu j is slope of dt by dp at constant enthalpy. Very important. This one already I discussed in a separate video. You can check it from my playlist. Some questions also I solved. 3 to 4 questions also I solved in that video. You can check it. Mu j, this is inversion curve. Where mu j equal to 0, this black color curve. Your enthalpy is constant, enthalpy is constant. This side cooling, slope is positive here. This side heating, slope is negative here. And here slope is 0. Slope is mu j. This is TP diagram. Also TS diagram also important for Joule Thomson coefficient. Here I will draw the TS diagram for Joule Thomson coefficient. Temperature versus entropy. In TS plot, these are constant enthalpy lines, constant enthalpy curves. This is inversion curve, black dotted line. Here mu j is 0. Mu j equal to dt by dp at constant enthalpy. So both are important. Temperature versus pressure curve and temperature versus entropy curve. Next chapter is compressible fluids. Here m is our Mach number, m equal to v by c. V is actual velocity and c is sonic velocity. Sonic velocity formula is c equal to gamma RT whole root over. Gamma is specific heat ratio, R is characteristic constant, gas constant, characteristic gas constant, and T is temperature. Sometimes in question they are not giving the values of gamma and R. So for air you have to remember gamma value is, it's diatomic gas, so it's 1.4, and for R value, air characteristic gas constant is 0.287, unit is kilojoule per kg Kelvin. So both value you have to remember. Sometimes they may not provide in the question. Next formula for stagnation point, TO by T equal to 1 plus gamma minus 1 by 2 into m square. One question they asked from this formula. Already asked in Isro, I think 2012 or 2013. This one already solved in my previous video. You can check it in Thermodynamics Isro playlist. And here TO is stagnation temperature and T is initial temperature. Then this formula is very important. 4 to 5 times they asked question based on this formula. For nozzle and diffuser, this is very important. dA by A equal to dV by V whole into m square minus 1. For inlet subsonic, nozzle and diffuser, here outlet will, velocity will increase and pressure will decrease. For subsonic inlet, in case of nozzle and in case of diffuser, velocity will decrease, pressure will increase at outlet if inlet is subsonic. Subsonic means m is less than 1. And for supersonic inlet, nozzle and diffuser. For supersonic inlet, supersonic nozzle will act as subsonic diffuser. Velocity will decrease and pressure will increase at outlet. And in case of inlet is supersonic for a diffuser, it will act as subsonic nozzle. In case of subsonic nozzle, velocity increases at outlet and pressure decreases at outlet. Like that, if diffuser inlet is supersonic, velocity will increase and pressure will decrease. And you have to use this mathematical relation also. You can prove it. You can check it from my previous videos. In Thermodynamics playlist it's available. Already I solved some question based on this formula. You can use this formula or directly you remember these 4 options. 4 conditions you can remember, then you can save time. Compressible flow through a converging nozzle. Here pressure at exist equal to back pressure this will decrease and this side it will decrease. Here pressure at exist is greater than back pressure PB. At 3 point ME equal to 1. And second graph, this is mass flow rate divided by pressure ratio. Here after 3 point, the mass flow rate will not increase, it will constant. At P star by PO, mass flow rate is maximum. So here at point 3, if you reduce that ratio also, mass flow rate will remain constant. One more thing is important here. Across normal shock, if inlet is supersonic and after normal shock, it will become subsonic. And here pressure, temperature, density and entropy, volume, Mach number, and stagnation temperature, stagnation enthalpy and stagnation pressure. This relation is very important. For IES and Isro examination, they won't ask this question. Pressure will increase, temperature will increase, density will increase and entropy also increase. V decrease, M is decrease, TO and HO both are constant. This is very important. TO and HO both are constant and stagnation pressure, it will decrease. Funnel line and Rayleigh line, both are important. In funnel line, it's adiabatic flow in a constant area duct with friction. It's adiabatic, so no heat, with friction. And in case of Rayleigh line, without friction, with heat. In case of Rayleigh line, flow in a constant area duct with heat but without friction. With heat but without friction. See, funnel line F is there, so friction is there, no heat. And in case of Rayleigh line, opposite, no friction with heat. This is also important. Rayleigh line on HS plot. Here, in this case, subsonic, here supersonic. And cooling region, heating region for supersonic case, and for subsonic case, cooling and heating. Direction also given. Here Mach number is 1. Thank you friends. Thank you for watching my video. Thank you.